In this video, I'd like to talk about the solution of problem 422. If a fair die is rolled 3 times, let capital X denote the number of distinct sides that appear. Find the mean of X and the standard deviation of X. To do this problem, we first have to find the distribution of X. The distribution of X means find the possible values of X and the probabilities for each. Well, clearly when you roll a die 3 times, you could have one side that appears all 3 times. You could have 3 different sides that appear, so x would equal 3. Or it could be that 2 are the same and then 1 is different. So the possible number of distinct sides that could appear would be 1, 2, or 3. So those are the possible values. Now we need to find the probabilities of each of these values. To do this, I gave the hint in the notes that this is the probability that all the sides are the same, while number x equals 3 is all sides are different. Now, what's the probability that all the sides are the same? Well, this is an AND question. The first one could be anything, and then the second one has to match the first, and then the third has to match the second and the first. So the first one could be anything, so the chance of that happening is 6 out of 6. The second one has to match the first, so if the first one's a 2, the second one must be a 2. If the first one's a 6, the second one has to be a 6. So the chance that the second die matches the first die is 1 out of 6. And finally, the third die has to match the first and the second, so that the chance of that happening is also 1 out of 6. So the chance that all the sides are the same, that one side appears 3 straight times, would be 1 over 36, 0.027778. That works out to be 1 over 36. Okay, now the chance of them all being different. Once again, this is an AND question. The first die can be anything. The second die can be anything except what appears in the first die. In other words, if the first die is a 1, then the second die could be either a 2, 3, 4, 5, or 6. So for the second die, there are 5 possible, or 5 favorable outcomes out of 6 possible. So the chance that the second die does not match the first die is 5 out of 6. Finally, the chance that the third die is different than the first 2 would be 4 out of 6. We've assumed that the first 2 dice were different, and so the chance that the third die is something different than the first 2 would be 4 out of 6. So that chance of that happening would be 20 over 36, in decimal about 5/9. Okay, lastly, we need to figure out the chance of 2. Now this could be logicked out directly. It's a little bit painful to do it that way. The easiest thing to do is to realize that these 3 numbers, chance of one side appearing 3 times, the chance of 2 numbers appearing, chance of 3 numbers appearing, these 3 things have to add up to 1. And so therefore, this one is going to be equal to 1 minus chance of 1 happening minus a chance of 3 happening. Okay, so this one was 1 out of 36. This one was 20 out of 36, and so this one, by subtraction, will be 15 out of 36, which in decimal is about 0.41666667. Okay, now that we have the distribution, we have the possible values and the probabilities for each, we can now find the mean and the standard deviation. To find the mean, that'll be equal to 1 times 1 over 36, this number here, plus 2 times 15 over 36, plus 3 times 20 over 36, where I've expressed these numbers as fractions as opposed to decimal, just to make it clear what these numbers are. So this is 1 out of 36, 15 out of 36, 20 out of 36. And so by taking the possible values and the probabilities for each, multiplying and adding up, I get the expected value of x, which is about 2.52. Next, we need the expected value of x squared. This is going to be 1 squared times 1 over 36, plus 2 squared times 15 over 36, plus 3 squared times 20 over 36. So this looks very much the same as what we had before, except I square the possible values. I do not square the probabilities, but I square the possible values and add them up. And so I get 1 times 1 over 36 plus 4 times 15 over 36 plus 9 times 20 over 36. So this works out to be 6.694. And so finally, to get the standard deviation, that will be equal to the square root of this number minus the square of the mean. And as I've said before, the thing under the square root here, it's the 6.69 minus 2.52 quantity squared. That has to be something that's bigger than 0. If that turns out to be less than 0, then I would get the square root of a negative number that's undefined. So that cannot happen. If that does happen, that means I've made a mistake someplace. And so finally, I get the standard deviation to be 0.552. So that's the solution for 4.22. First, we find the possible values and the probabilities for each. Then we find the mean and then the standard deviation using the distribution up here.